Alright, we're going to create some graphs and calculate some stuff with our bowling ball data. The first thing I want is speed, and that will be in centimeters per second because that's what we measured in. And to get that, I do change in x divided by change in time. I could have subtracted these two numbers to get my change in x, but I don't have to since we already measured it. We might as well just use that value. And then once I have my formula entered correctly, grab the corner here and drag it down. Those are my speeds. And to get acceleration, which will be in centimeters per second squared, I do the same thing as before, except now I want change in speed divided by change in time. So how much did my speed change by, divided by how much my time changed by. Same thing, click and drag, and I'm cool. Some of your numbers might be a little bit crazy, like here. This just means somebody was not really paying attention when they took the time data, and then those errors in our data just get progressively worse as we calculate more and more things. But don't stress out about that too much. So let's import this into Plotly so we can get a nice looking graph. Google Sheets is not terribly good at making graphs, but Plotly is really good. And you can see it copied all of this stuff in pretty nicely. For the first graph, we're going to do position. So it's a little bit strange, but position is actually our y variable, even though it's an x here. And time is always going to be x. So we want, make sure your colors match. That's fun. There we go, blue and blue. Time is always x. And it makes sense to graph your positions together. So make this time in x and make this position a y. That way I can just put them on the same graph. Always scatter. People in physics love scatter plots. And this is cool. So this is my bowling ball lab. And this is position measured in centimeters. And this is time measured in seconds. And if I'm just a typical physics student, I can go ahead and print this off and I'm good to go. If I'm in honors, I may want to add a fit. And we expect there to be a quadratic or polynomial fit for this data. This would be second order. And we can run it. And then we get that nice curve. Even though our data is a little bit messy, we get a nice looking trace here. And we can add for the other plot as well. Quadratic will work just fine. You don't have to do second order polynomial. Quadratic means the same thing. So I can run that for orange. And look, our data is actually quite nice. When I want to print, I need to export as a PNG. And then this thing will print out on a Chromebook a lot nicer than if you were printing directly from Plotly. All right, that's it.